Good morning, ma'am. Today I, Priyanshu Khera, and my team will be explaining the topic polyurethane and silicon polymers. So, first we'll take a look at polyurethanes. Polyurethane is a polymer composed of chain of organic units joined by carbamate urethane links. Most of the polyurethane are thermosetting that they don't melt when they are heated, but thermoplastic polymers are also available. Polyurethane are used to manufacture non-flexible, high-resilience foam seating, microcellular foam seals and gaskets, durable elastomeric wheels and tires. They are also used to as high-performance adhesive surface coating and sealants, synthetic fibers, and hard plastic parts. Polyurethane are commonly formed when reacting di or poly isocyanate with polyol, as like you can see in the figure. The physical properties of polyurethane are highly dependent on the manner in which they are produced. For example, if the polyol chain, which is used as a raw material for the preparation of polyurethane, is long and flexible, the final product will be soft and elastic. On the other hand, if the extent of cross-linking is very high, the final polyurethane product will be tough and rigid. The other physical properties of polyurethane are hardness, high tensile strength, high compression strength, impact resistance, abrasion resistance, tear strength, and resistance to oil, water, and grease. The application states that when scientists discovered that polyurethane could be made into fine threads, these are combined with nylon to create lightweight and stretchable materials. The most common use of polyurethane in major appliances is in rigid foams for refrigerator and freezer thermal insulation system. Polyurethane based binders are used to composite wood products to permanently glue organic products into oriented strand boards, medium density fireboards, laminated veneer lumber. Non-foam urethanes are frequently used in electrical and electronic industries to encapsulate, seal, and insulate fragile microelectronic components and underwater cables, which are referred as spotting compounds. The polyurethane are mainly used in home furnishing, mainly furniture. Flexible polyurethane foams work also as to make the furniture more durable. Only two species of Ecuadorian fungus are capable of biodegrading polyurethane in aerobic and anaerobic conditions. Polyester type polyurethanes are most easily biodegraded than polyether type.
Hello everyone, I am Mehak Khan and I'll be talking about silicon polymers. So, silicon polymers are the type of polymers whose backbone is made up of repeating silicon to oxygen bonds, that is, siloxane bonds, with organic side groups such as methyl, phenyl, or vinyl. The basic repeating unit is known as siloxane, and the most common available silicon is polydimethyl siloxane. The general formula of silicon is R2SiOX, where R belongs to any of the organic groups. Now, if we talk about the structure of silicon polymers, it has an inorganic silicon oxygen backbone chain where two organic groups are attached to each silicon center as shown in the given image. Coming to the next slide, silicon polymers contain repeated R2SiO units, which is clearly depicted in the given image. Also, polymeric solution in silicons are held by weak van der Waals forces. They are liquid of varying viscosity or gums or solids containing polymeric molecule which is generally soluble in organic media. Now Kritika Rawat will further talk through this topic.
Hello everyone, my name is Kritika Rawat and I'll be explaining about the properties and uses of silicon polymers. Firstly, talking about the properties of silicon polymers. Silicons have low thermal conductivity and chemical reactivity. This is because their molecular structure limits the flow of heat. Additionally, their low chemical resistivity is due to the stable silicon oxygen bonds in their structure. Their toxicity is also low because they are chemically inert and biocompatible. It can repel water and form watertight seals. It has high resistance to oxygen, ozone, and ultraviolet light. It has both electrically insulative and conductive properties. Silicon polymers generally have low electrical conductivity. However, certain modifications in their structure can introduce electrical conductivity. It has high gas permeability and high thermal stability. They are superior solvents for organic compounds. This can be due to few reasons. First, they have low surface tension, which means they can spread and dissolve compounds more effectively. Second, they have a high thermal stability, allowing them to dissolve and handle a wide range of temperatures. The last point of the slide is, if silicon is burnt in the presence of oxygen, solid silica is formed as a white powder as well as char and various gases. This white powder is often called silica fume. Now, moving on, I will be explaining about thermal stability, chemical reactivity, chemical stability, and some other properties. Thermal stability. The silicon oxygen bond in silicons are shorter than the expected silicon oxygen bond calculated from their radii. Therefore, it shows some ionic character in silicon oxygen bond, due to which it becomes quite stable. Chemical reactivity. Siloxane bond can be cleaved by Grignard reagent and lithium aluminium hydride. The siloxanes undergoes hydrolysis and alcoholysis at elevated temperatures in presence of strong acid and base to give silanols and alkoxysilanes. Chemical stability. Highly polar character of silicon oxygen bond and the ability of silicon to expand its valency utilizing its d orbitals renders polysiloxanes susceptible to attack by various reagents. Strong acids and bases may cause depolymerization, like some electron deficient salts may cause cleavage of silicon oxygen bonds. Some other properties. Polysiloxanes are water repellent, and as we know that they are electrical insulators, they are transparent to visible light but absorbs considerable amounts of ultraviolet rays, especially of shorter wavelengths. And now I'll be presenting some uses of silicon polymers. Silicon rubber. Silicon is used as rubber in various applications because of its unique properties. It is flexible, durable, and has a wide temperature range in which it remains stable. These are commonly used for sealing and electrical insulation. As insulators, due to their excellent electrical insulation properties, they are used as insulators. They have a high dielectric strength, meaning they can withstand high voltages without breaking down. Silicon oil. Silicon polymers are used in silicon oil because they provide excellent lubrication and heat resisting properties. The polymers give the oil its smooth and slippery texture, making it useful in various applications like lubricating medical devices, damping shocks in mechanical systems, and even in cosmetics. Silicon grease. The polymers help the grease adhere to the surfaces, reducing friction and preventing moisture or contaminants from entering. It is also used for lubricant for making waterproof clothes. And lastly, silicon polymers are also used in paper for making enamel. At the end, we got to know that polymers have a wide range of applications and uses in various fields. Thank you.